Okay, so what I'm doing here is I'm very slowly introducing a few things at a time. This is the two example spreadsheet is an example of two data sets. In Excel, it's possible to have more than one data set present on something called a sheet. And the way you identify that is down here in the lower left-hand side, you see one sheet that says age height. And if you go over here, the next one over here says pressure, and that has to do, I believe, with tire pressure and temperature. And what we see here is a small data set of 12 observations. I've got the first variable names in the first row, and I've got the data here. Just to rehearse what we did before the last time, the very first time that we started playing with scatter plots, it's possible to come in and do a really quick scatter plot by using the insert command. Let me just delete this thing. If I like these data, I might be interested in making a scatter plot. So I'll come in here and make my scatter plot. And then underneath the options, I can say, hey, give me a trend line. And I can say, hey, I would like that trend line to be a linear trend line. And this is the regression line. Housekeeping here in the chat, so that is there. And we talked about the fact that, this probably tells me there's a really nice linear relationship going on between my predictor and my criteria. Similarly, just as a quick way of looking at things, that other file has a relationship going on, but one of the data points has been miscoded. I went in and purposely changed this 79.99 to a 9.99. So we see here, hey, there's something dramatically wrong with my data. And looking at my trend line, I can say, well, yeah, I kind of have the same functional relationship. The intercept is a lot different. If I extend this line out to 0, I'm going to hit a different number than if I extend this line out to 0. But the important thing is, I looked at the data and I flagged it. And you can do that inside of Excel. It's quick. And if you don't like playing around with R, it's a really easy way to start things off. Let's come back now to take a look at our RStudio cloud example. So inside of this, you can come back up to your workspace and you can say, I want to make a new project. And if you click that button, it will sit there for a while and say, here's a new project. What project means is all of the data, all of the programs, all of the plots that you create are now going to be specific to this new project. So sometimes when you're working on things, you might have, say, the first week's data that you gathered, or you might have a different research project you're looking at, and you want to keep all the files from one project separate from another project. And in order to give that a name, up here next to Untitled Project, you click on that, and you can then type in something like that, and that will give you a new project name. In my case, I'm hoping you're not getting that message. In my case, in prepping for class, I already made a project called 2 examples. And we'll go through what I've written here, but what I want you to do is at this point, make a new project and call it 2 examples. And flag me in the chat button and we'll fly back and give you some help if you need it. bounce me a chat if there's problems here. Now, inside of RStudio Cloud, we can import these two Excel spreadsheets. So we can take them from our local computer and put them on the cloud. And we do that in the lower right-hand corner. And we say, hey, here's our files. So to do that, I'm going to hit the upload button. And it will say, okay, I'm going to target this to my directory. And I'm going to choose the file. In this case, for example, the bad data set might be one that I would like to upload. I click on that and hit open and OK. And that's going to upload that bad data set to my file. So what I'd like you to do now is to upload the two examples Excel spreadsheet and the two examples bad data set Excel spreadsheet. Okay, now as we said before, this gets your computer up into, this gets your data up into this virtual file. So now these data sets exist down here in our cloud. They're Excel data sets, and we have to go through the step of making those things into data files. And there's one way that we talked about before, and doing another message offline. And I'm going to show you a new way that is also an option. The easy way that we talked about before is to come up here in the upper right-hand corner. Okay, I'll be with you in a minute. Let me finish the statement of grace. And type in import data set. And we can say Excel. And we then need to hit the browse button. And we can say, for example, select the two examples data set. And gives you a preview. And then you can hit import after that. In your life, you might be doing analyses in your research team, and you might get really bored with having to go through this import data set step all the time. And for that reason, sometimes inside of your code, and I'll make this a little bit bigger so we can read it, there's another package here where you can which you can install, which will then have that import happen in one line. So that all you have to do is open up your R code and merely hit the run button. And the way that it's doing that is with this little function called readxl. So in order for you to have this readxl app available to you, you'll need to go into the tools section and install readxl. And given that RStudio Cloud takes its own sweet time doing that, why don't you install readxl now? And then I'll turn back to Grace, because RStudio is going to take a little while to do that. Grace, do you have happiness?
So I just uploaded the data sets.
Okay.
So that worked.
Yay.
So that's where I'm at now.
Good for you. All right. So you could either import those data sets, or you can kind of skip now if you'd like to installing readxl. Or you can do both. I mean, it's only clicking. Anybody else?
How do you install readxl?
Okay, so what we do is we come up to this top section, which I'm hoping is kind of turning blue on you as I go over, and you come over to the tools section, left click on that and hit install packages. And then you can put in the name here, and you can type in readxl and then hit install.
Okay.
Good. I should point out that you are now doing things that other people who teach this class in other sections have told me are absolutely impossible. No one will ever do it. So I really appreciate that you're hanging in there with this interface. But again, as I said, this is going to produce benefits to you after college, and more importantly, to what you care about next semester.
It's saying that one or more of the packages to be updated are loaded and restarting R prior to install is highly recommended.
You can do that.
Okay.
Hit yes. And it should come back and just put you back to where you were. And you should see your R script again.
Yeah, I think it worked.
Good. So after it's installed, put your cursor anywhere on the first line and hit the run command. And you will see the library statement. And before we run the second line, let's just look a little bit at what's going on here. I'm making a new data set called age and height, all lowercase. And I'm using the readxl program to do that. If you ever want, just for later on, I don't know if you are also seeing, there's this little yellow. Oh, okay. You're only seeing the data tables. You can get out of the data tables by clicking the X next to them. So what happens when you import a data set? Let me just mimic the behavior here. So here I go, I've imported it. And now notice it's going to show me this data set over here. And over on the left hand, my program is still there. So if I don't want to look at my data anymore, I can click the little X and get rid of it. Is this good?
No, it got rid of everything.
Okay.
Perfect.
So your ARP, oh, okay, but maybe you have not yet created an R file. That's silly me. I didn't tell you to do that yet. So up underneath File, New File, make an R script. Thank you. I was getting a little ahead of myself.
Sorry, can you show how to do that again?
Sure. Up here in File, going to left click, move the cursor down to New File, and move over to say R script. And that will give me an R program.
Okay.
Just to make typing easier, let me come into this part, and I'll give you all that code there. So this is going to save. So make a new R script, copy what you see in the chat, and paste it into that R script. Okay.
And sorry, when I did that whole process, it also just got rid of the data set again instead of like, because like when I clicked the little X up next to it, it just like closed out the whole window.
Okay, let's come back. Share your screen.
Okay.
We'll get you fixed up here. Here we go. All right. Anything else? So now let's take a little moment and talk about the second line of code. I'm using the readxl package, and I put the name of my Excel file. And if you're ever, a little curious about, is the name there? Well, you can come down to the lower right-hand corner and you can see the name of your file to examples.xls is there. And then inside of your Excel sheet, your Excel file, you need to tell it which sheet to look at. So in this case, it's age, height. So anytime that you're wanting to play with this and do some analysis, you can now just run line 1 and run line 2, and it will create the age and height data set for you. Everybody on the same page, so to speak, on this? So prior to this, we talked about using this little bit of code to do a regression model. And in this case, my syntax was my y variable, that little squiggly line known as a tilde, and then the predictor variable. And then I can put a comma after that and say data equals and the name of my data set. Now in this case, what I'm doing is I'm making a new file, a new data set here, which contains the results of my regression. And I can then print out the results using a summary statement. So to talk a little bit about that, put your cursor on line 3 and hit the run button. And life should be happy. And then on line 4, hit the run button again. And what you'll see is exactly what we talked about before. Here's what our regression model is. It will give us a summary statement of how big the residuals of predictions are. So if I take the observed height minus the predicted height based on age, the smallest residual I have is 2.8. That is, somebody scored 2.8 points below their predicted value. The median, that score below which half of the residuals fall, is around 0.03. And the largest is 0.46. In other words, somebody had a height that was 0.46 points higher than their predicted value. Next, we see the regression coefficients. So the intercept, excuse me, is the predicted height if somebody had an age of 0. So generally speaking, that isn't terribly interesting to us. And this next number, 0.63528, is the regression weight. So that tells us for every year that we increase, we should expect to see a 0.63528 increase in height. On the right-hand side, this number is the probability, is the p-value. So that's equivalent to saying, hey, I have 10 zeros, 3, 2, 1. In other words, when people are doing regressions, they kind of shoot over to this column to look at what's interesting and what's not. This standard error, whenever you see a standard error, you can just think that's an estimate of what the standard deviation of a statistic is if I were to do my study over again. So we're saying in our study, we observed this time 0.63528 as the regression weight. Now, if I do my study over again, I'm not going to get exactly 63528. It's going to bounce around a little bit. But generally speaking, based on normal theory, I'm going to expect that to jump around with a standard deviation of 0.02. Statistical significance represents the odds that your data could have occurred under a theory. In this case, the theory of the null hypothesis that the real regression rate is 0. Behave yourself. And in this case, the t value, which you can think of as kind of a z-score, is 30.8, 30.65. That means, that's kind of significant at the OOG's level, that it's very unlikely that the null hypothesis is true and that the true population regression rate is 0. Downstairs, you have our little stars that indicate the significance level. 3 stars means less than 0.01, 2 stars is 0.1, 1 star is 0.5. Downstairs here, we see an R square. In the case of a single predictor model, that R square is the square of the correlation between age and height. Any questions on this? Is that working? Now, over here, kind of this down a little bit. Notice I have a data set here called LM height. So everything that got calculated with my regression got written to this data set. And there's a whole bunch of things in here. We're not going to get into that right now, but it's saving residuals, it's saving predicted values, it's saving lots of summary statistics for you. All right. When we talked about the Anscombe data set, we said, you know what? Don't believe a correlation coefficient, any statistical significance of that correlation coefficient until you use your eyes to take a look at the data. In the Anscombe data set, it was really kind of nice because it was a really small data set. And to rehearse, when we talked about that lecture, we said, maybe I shouldn't, here are some reasons why I shouldn't believe a correlation coefficient. Maybe I shouldn't believe a correlation coefficient because a straight line is not what's going on in the data. It might be a curved line. It might be a line that increases for a while and then levels, plateaus off. Maybe it's the case that I shouldn't believe my correlation because there's somebody who is an outlier. That is, they have a really large error of prediction. Maybe I shouldn't believe that correlation because there's an influential observation that if I wouldn't have been so lucky as to get this person and I redid the study, I wouldn't have observed the correlation that I computed based on the data, that namely that individual is an influential observation. Well, if you have a large data set, a scatter plot is going to be really hard to look at. So statisticians have developed some measures of outliers and leverage, and they've kind of tried to get some statistics that represent a compromise of both of those things. In order to calculate these statistics, we need to use a new package. And in this case, it's olsrr. So while I'm talking about it, come up to the tools box and install a new package and install olsrr. And the nice thing about doing these installs is once you've installed it once in our Studio Cloud, you don't have to go back and redo it again. if we think about residuals, one of the things we would look at for testing if somebody is an outlier is whether their observation falls a long way away from their predicted value. And I'll have more to say on Friday about exactly why we're calculating this particular residual. But if we want to look at residuals in the data, the line function that we use is OLS plot resid student, which calculates something called a studentized deleted residual. I'll talk about more of that on Friday. If we run this command, first of all, we'll have to do with the library statement, hit the run command, and then on line 6, we'll hit the run command again. And downstairs here, we'll get a little plot. And what you want to look at is, so what we're looking at here is a plot of all of the residuals, all of the errors of prediction in my data set. Generally speaking, if these residuals do not cross this red line, we're saying those residuals are not huge, that there isn't any one person who has got a really bad residual. So as you're looking at that, everybody got a studentized residual plot?
Mine hasn't been running since like the third line. It didn't get the third line to run because it said there was an error in contrasts.
Okay,
I put it in the chat, but
I'm sorry. Oh, I've been getting messages here and it hasn't been scrolling down. Let me take a look at all these first. Okay, I got it. I got an error. It's wonderful that you're helping each other. Okay. So. Thus far, the residual plot. So as you're looking at things, if you start seeing observations that fall outside those red lines, that tells you there's something about that person. It's a little bit different. Coming down to line 7, if we run that, we're going to see a plot of the residuals by something called the lever. So remember that one of the ways that the way I talk about regression, it's a little bit different than the book, is that there can be an outlying observation and there can also be an influential observation. And the way of testing to see if there is an observation that is influential is by something called the lever. And the easiest way to communicate this to you is just to show you the plot. What we see here is a plot of the studentized deleted residuals by the lever. And what you're looking at here is if they fall outside these red lines, maybe under the joint consideration, we might have an outlier for observation number 3. There's nobody over here past this value for the lever. So in this data set, nobody is influential. The picture is going to be a little different when we consider the bad data set example. We'll have somebody who's way, way, way gone in terms of being outlying and is also influential. But that's another plot. And then when you're trying to cut through data, maybe it's not that, maybe we would kind of like to have one summary statistic that will let us know if a given observation is suspect. Cook's D is a statistic that is a compromise between the studentized deleted residual and the lever. And the way to get a plot of that is to run line 8. And based on, and the interpretation is the same as it is before. These are our observations. Based on Cook's D, maybe observation 1 and again observation 3 would count as observations that are a little bit, suspect, and you might want to follow up on. So we're kind of at time today. We'll pick this up on Friday. If anybody in the class is having problems running this, let me know. Some of you have been chatting me privately that it's not, you're not having access to a computer at the moment because you're watching on your phone or something. That is fine. If office hours don't work for you, email me. We'll set up another time, at your convenience to get you squared away on this.